Today, we're talking about DEX Aggregators with Matt Deible. Matt, thank you for joining us.
Absolutely. Thanks for having me.
Matt, over $1 trillion has traded through DEX Aggregators this year alone. And DEXs are especially important when things like FTX happened, because people realize more and more that if you don't own the keys to your own crypto, then it's not really your crypto. And if you're trusting someone else with custody, then there's an inherent risk there. But if you use a DEX, then you never have to give up custody, which means you don't really have a risk. And so this $1 trillion that's trading through DEX aggregators is likely growing. And it's already 10 to 20% of trading volume that goes through centralized exchanges. So it's really important that traders understand what DEX aggregators are and how they work and how to actually get the best prices for their trades. So before we dig in, I'd love to understand a bit from you about what makes you such an expert and guide on this topic.
I guess I'm somewhat new to crypto in general. I got into it for the first time about 2 years ago. I come from a AI background, so I was interested in studying AI problems, and it just so happened that I found AI problems that related to crypto. So it was actually related to the many actors within the graph protocol. And that was sort of my entrance into crypto. And then from there, just starting to learn about all that crypto has to offer and all the new mechanisms. And one such mechanism that's particularly interesting is the DEX and the AMM, right? And so for about a year and a half, I've been intensely studying these AMMs. And basically, the sub problem within these AMMs that I'm studying is how to sort of solve from the trader's perspective the problem of figuring out how to trade through them. Because the high level is that there's many different types of AMMs that try to accomplish different things, and liquidity is fragmented across these AMMs. And we can get more into the different types of AMMs and why they exist, but it ends up being a very hard problem and a very interesting problem to figure out how to route through these many AMMs. And so that's what I've spent quite a while now studying while building the DEX aggregator Odos.
Awesome. Okay, thank you. So why don't we start from the beginning and understand like what is a DEX aggregator and what is the purpose of a DEX aggregator?
Absolutely, yeah. So I mentioned there's lots of pools, and basically what AMMs do, or most AMMs, what they do is the larger your trade size through them, um, the worse rate you're going to get, right? They sort of have this automatic price adjustment mechanism. So often what you get is with large enough trades or even very small trades on low gas networks, it often is worth the gas to send it through multiple dexes and to split your order through multiple dexes and potentially even trade through intermediate tokens. And of course, having a user go to 10 different UIs and execute 10 different trades is not really reasonable at all, and would also use a lot of extra gas because, of course, every transaction has a given gas overhead. And so, what DEX aggregators do is they not only figure out how to optimally route your order through all these DEXs to maximize the returns, they also give you one single transaction that you can just sign and send that will execute all of those swaps for you at once in order to get that best return.
Okay, got it. So it's kind of like kayak.com in the travel space. You want to go from A to B, and instead of going to United and Delta and, Spirit and JetBlue, you just go to kayak.com, you put in where you want to go A to B, and then kayak.com shows you, all the flights and the routes, and even combines multiple airlines sometimes for multi stop trips to get you where you're going the quickest and the fastest.
Exactly. Yeah. Yep.
Okay, great. And I just want to make sure we're also level setting on this concept of slippage and gas. So in general, DEXs work differently than centralized exchanges, which have a central limit order book. It's what we traditionally think of as, how you match orders and set a price. There's buys and sells. And in AMMs, instead, you have a pool of capital in a smart contract, which is a piece of code on the blockchain. People put assets in that pool. So let's say it's ETH and USDC. And then traders can use that as trading inventory to switch one for the other at a price determined by the this DEX itself, this AMM itself. And obviously, the AMM doesn't want to have all its ETH taken and switch to USD or vice versa, because then it wouldn't have inventory to trade anymore. And so basically, it imposes slippage, which is the more you take out of that pool relative to the size of the pool, the worse the price is. And that's, it sounds like from what you're saying, is what necessitates, you know, taking a big trade and splitting it up over multiple pools, or figuring out which pool has the best price and the least slippage at a given time, even though there's this idea of gas, which is like a transaction fee for just the processing cost of doing anything on the blockchain, that you also have to pay for the more kind of actions you take. Is that, does that supplement
Right.
correctly?
Yeah. Yeah. So there's really, I guess, maybe you could say three things at a high level. There's the like current ask price of each DEX. Like if you were just trading an instantaneous amount, what does the price start at? And then there's how quickly this price adjusts as you trade volume through it. And this is the one of the most complex parts, because each DEX can do this a different way, and figuring out how to optimally deal with these mechanisms is the main problem we're solving. But then there is also, of course, this gas cost. And so to put it concretely, what we are optimizing as a DEX aggregator is the value of the output minus the value of the gas. So we seek to only add complexity when basically the value of the gas you're paying is less than the additional output that you're getting.
So, so why is this a hard problem? Talk us through like how a DEX aggregator actually architects itself to deal with this problem, because there's like thousands of different pools and thousands of different assets, right? I mean, what are the, walk us through the various complexities you have to deal with.
Absolutely, yeah. So we can think about maybe like an increasingly complex solution. We can start off by just thinking of maybe we have a list of DEXs and we just check each one, right? And so for a given order, we check each DEX, and whichever one has the best price, we send you there. That would be like the simplest aggregator. But of course, as we discussed, there's other options, right? You can split between each one. So now we can think, okay, now I will also consider half, like every combination sending half through each. And maybe you find a different solution there, right? But really it's sort of, you have a continuous spectrum. Like you can send 1.5% through this one and 98.5% through this one, so that there's a lot of complexity there, and you can split between any of these dexes. Now we can also think about routing through intermediate tokens, right? So this is sort of triangular arbitrage in some way, where the price from trading through another asset may be better than trading directly to the asset. And so that's another option that we have. And so you end up with just a combinatorial explosion of sorts of possibilities that uh, you can end up routing through. And it's searching that space effectively that becomes a DEX aggregator's problem. And now, specifically with Odos, one of the things that,
Before that, can you give us an example of how you might split hops and go through multiple tokens,
yeah,
just to
from
make
like a,
sure everyone understands, like walk through a specific trade that might hop through multiple tokens.
okay, sure, yeah. So let's say you're trying to trade 100 ETH to USDC. You're trying to liquidate your position. Now, that's a very large trade, obviously. So it's likely not going to be ideal to send that all through one DEX. So let's say first you take 40 ETH and you wrap it with wrapped ETH. You may take 60 ETH and we may send that through, let's say, Hashflow, and that'll turn into USDT. So now we have 40 ETH and 60 USDT. We can further split that wrapped ETH and send some, let's say 20, over to DAI through Uniswap, and we can send 20 through directly to USDC like we want through SushiSwap. So now we have some amount of dye and some amount of USDT, and we can also further split those. I guess I won't continue to complicate this route, but hopefully the sort of concept of splitting and sending through other dexes, potentially through other tokens as well, is clear. And this complexity can get uh, extremely large.
Yes. Okay. That sounds like a lot higher than I can count. Okay, got it. So these are the problems. And it seems like there's another problem too, which is gas is like not entirely predictable, right?
Yeah, so that's definitely a factor. So the like when you're doing a routing, you have to make some assumption about what the gas will be when you actually execute the transaction, and as you just said, that could change. In which case, the route that you come up with is not probably optimal for the gas that you're actually going to be charged at the time. And so that's definitely a factor. I think generally it's still going to be close. You should be paying slightly higher than market gas in general, just to get your transaction through and not suffer slippage or any other adverse effects like RFQ deadline expirations. So generally, you should be bidding a little higher, and hopefully that'll get your transaction through, and the changing gas will also be less. But yeah, that's definitely a factor as well.
So you can solve the gas need problem by guesstimating and then always paying a little bit more. And so you know that your gas is going to be roughly fixed because you're always paying a little bit more.
Right. Yeah.
Makes sense. Okay. So thank you. And I cut you off. You were going to go into how Odos and you handle this complexity.
Right. Yeah. So going back to complexity, one of the reasons we built Odos in the first place is that we sort of saw that we had a solution that seemed to be unique and seemed to consider solutions that other aggregators did not at this point in time. And hopefully I can try to explain this in a simple way. But basically, what we do is if you look at other aggregators, they will split between intermediate tokens, but then they'll just start sending it through one token at a time, maybe through multiple dexes, but through one token. But what Odos considers is splitting between tokens, but then each of those tokens splitting and sending to other tokens as well. And so you end up with sort of an interweaving path instead of just a split and then linear paths. And so that's a much wider space to search. It's much harder to search, but it can also lead to better solutions.
I think so. So another DEX aggregator may say, okay, we want to go from, link to USDC, and link will split into several. We see several pools. There's a link ETH pool that has low slippage, and then there's an ETH USDC pool that has lower slippage, and so they might route through that. And by the way, there might also be another pool which is USDT, so they're going link to USDT and then USDT to USDC. And you're
Hmm.
saying that actually that's kind of like a first level split. And you're saying actually that second hop too, you might want to split between multiple tokens, and so you get a split at each hop, and
Right. Yeah. We
and
consider
that's
just
actually
yeah.
even more complicated.
Hmm. Yeah, and so you can see we have this sort of unique visualization for that as well because we found that the visualization method that existing sort of solutions use, there's sort of an industry standard, and that visualization method can't really accommodate this extra complexity. So that's also part of the reason we explored sort of this unique visualization. So we use a Sankey diagram that's able to show sort of this unlimited complexity in splitting and interweaving.
I mean that's an interesting point, which is this is impressive complexity, but if you can't really show the difference and visualize it in a convenient way, it's hard for people to even conceive of how you're actually better, or if you're better. You know?
Exactly. Yeah, I think it's
Yeah,
yeah, it's a huge user experience advantage, even if you are getting slightly better rates to actually be able to visualize that effectively and hopefully intuitively as well. The goal was to sort of get something that you can just look at and sort of have an idea of what's going on and where your assets are flowing without looking at a bunch of numbers.
makes sense. Okay, so this makes sense. but it still seems like a pretty big technical problem. And I'm sure there's kind of multiple ways to go about it. So, do you have a sense for, the DEX aggregators out there, right, are Odos, 1inch, 0x, OpenOcean. There's a few more. Do you have a sense of like what their view would be on what the optimal way to approach this problem is, and like how the different yeah how I guess what other approaches you think there are to the problem besides this? I mean, everything's a trade-off, right? So different people are presumably making different trade-offs and different priorities.
If you're searching a much larger search space, you have to expend a lot more resources, and maybe you can find a better solution, but maybe it's better by 0.001%. And maybe there is no better solution at all. Maybe the best solution doesn't involve a lot of complexity, especially on something like Ethereum mainnet. Um, and so I think there's sort of this idea of diminishing returns, I guess, and I think it may not be worth it to go further down that curve. And I think we've potentially gone a little further down that curve, and I think we have gotten significant gains, but it's definitely the advantage of a lower complexity search space over maybe a single DEX might be bigger than going from that to like a much higher complexity search space, if that makes sense.
Makes sense. Okay, got it. Okay, so I think we have a good level set now about what a DEX aggregator is, why they exist, a bit about the different approaches. There's also a lot of different sources of liquidity, right? There's various types of AMMs, there's RFQs, there's private market makers. Like, all of these have different interfaces and have to be integrated in different ways. Can you talk a bit to us about the differences in aggregating those different modalities of liquidity sources?
Right. Yeah. And this is a very large amount of our work now is finding new dexes and integrating them. And as you said, each one has a custom sort of smart contract interaction. Even when the mechanisms behind the scene are the same, they might still change the smart contracts. And so that's a additional sort of interaction we have to handle. And to maybe give a little bit of motivation here, it turns out in general that how good you are at searching the space is quickly becomes less important than your coverage of the space in terms of liquidity. If you're missing a top DEX, you're just not going to be able to find very good solutions. And even if it's a smaller DEX, but it is very capital efficient, you are still going to be suffering a lot in the solutions you can provide if you aren't able to sort of accumulate a large majority of the liquidity available. And so, yeah, there is a that is a big focus for us is integrating all of these, which has to happen at multiple levels. We have to figure out how to monitor basically the state of the pool because that determines the pricing and how we can most effectively route through it. We have to consider how to route through it itself. So, how does it determine pricing, and how can we include that in our algorithm? And then finally, the smart contract interactions, as you mentioned. How can we actually then include it in this system of smart contracts on chain such that we can interact with it atomically and compose it with all these other AMMs and RFQs and whatnot?
Hmm. How do you feel about private market makers and AMMs in particular? So, you know, imagine the hash flows of the world, right, which are
Hmm.
providing private liquidity. They have trading firms who are making quotes, and hash flow basically offers those quotes versus composable sets of liquidity like Uniswap or Clipper, which is a hybrid.
Hmm.
I
Yeah.
mean,
So
both in terms of how you actually incorporate them into a DEX aggregator, but also like how you see the role of those two types of approaches in the market going forward. Like which is better?
yeah. So I think they both have very definitive strengths and weaknesses. They both, yes, there's a big trade-off there, I think. I think this request for quote mechanism in general is extremely powerful to sort of bridge these two worlds. As we mentioned, these DEXs, the one of the big advantages, especially in the wake of the past weeks, is that you control your assets completely. You execute one transaction, but even within the time of the transaction, you get your assets back. They're never like leaving your ownership for like an actual amount of time, right? And so maintaining that mechanism while also accessing centralized liquidity is extremely powerful, and that's what this sort of request for quote mechanism allows, sort of this centralized, more efficient potentially pricing. And so I will say that's one advantage of RFQs, is that you're not constrained by resources of the blockchain. You can sort of either more quickly update your pricing, or you can access information that's not accessible on the blockchain. And you can use all that to more effectively price the assets. And then you provide this interface back to the blockchain where you basically provide a quote and a signature, and we can then compose that with AMMs in our paths in all this complexity, because basically at that point it just becomes data that we can take on chain and execute a function to facilitate the exchange of assets. And so maybe real quickly, just to speak to the trade-offs here, is the main trade-off is basically you get more efficient pricing, but you're adding this extra sort of centralized dependency for the pricing, right? The pricing might not always be available and up, but you are getting more efficient pricing. So that's the main trade-off, I
Hmm.
would say.
But I mean, if you're getting more efficient pricing when it's available, and most of the time it's available, how come virtually all volume doesn't go through these RFQs with private market makers with off chain capital? That really isn't a DEX at all.
hmm Yeah, so maybe I should clarify what I mean by better pricing as well. That would be good. So I mean better pricing from the perspective of the liquidity provider, which may also mean better pricing for the trader, but maybe not, right? So DEXs, most DEXs have this sort of price discovery mechanism, which means the price may trail what market price actually is. And so a DEX may actually be offering the trader a better price than market, right? And if that gets sufficiently big enough, maybe it'll be arbed away, but there's usually a significantly basically a significant lag time where the better price is not going to be arbed away, but a trader can take advantage of it, if that makes sense. And so, what I mean by better prices for RFQs is that they're better prices for the liquidity provider, in that it allows the liquidity provider to manage their risk and to accurately price assets, which may also provide better prices to the trader, but also maybe not.
I see. So AMMs, because they need trades or arbitrageurs to bring their prices into balance, will sometimes offer worse prices from their perspective that are off market, but work to the favor of the trader and work out to a better price for the trader. And so for that reason, there's always going to be you know, there's always going to be a lot of flow that goes through AMMs because they're actually kind of almost subsidizing the trader. The trader is almost providing a service to the AMM.
In some ways, yeah. I mean, so how bad a price is to the liquidity provider ends up being dependent on future price action, essentially, because it matters where the price goes in the future to decide if that exchange you provided was actually good. But yeah, in general, yeah, the AMMs are not able to sort of watch the rest of the markets for liquid assets in high fidelity and like constantly update their price and like react to what the market's doing. So a combination, I think,
Hmm.
is very, very useful.
But it also seems like the AMMs them are getting systematically bad trade flow, right? If they are only getting flow when you know they're off market in a way that's probably detrimental to them, then you have these RFQs siphoning off the kind of trade flow that's better and more sustainable for the liquidity providers, and it kind of leaves the AMMs in a bit of a bad position.
Yeah, that's an interesting perspective, I think. Um, I think the other factor here is just like how much money is locked, right? There's a limit to how much trading you can facilitate. Like there's an upper bound in how much money you have locked, and right now AMMs have a lot more locked, so they can
Mm,
facilitate a lot larger trades. So if you have a very large trade, they're probably also going through AMMs right now. Yeah,
I see.
it's
I
interesting.
see. Have AMMs actually might have a lower cost of capital. They can get a lot more capital cheaper because it's kind of, I guess, anyone in the world who's potentially being a liquidity provider. Whereas these private market makers actually have quite a high cost of capital because, it's their own capital. They may be borrowing, or levering themselves up. And so they have to pay an interest rate and have a cost of capital there. And there's all these other things they could potentially be doing with their money, like arbitraging or whatever it is that sophisticated traders and trading firms do. And so, because they have this high cost of capital, they essentially have a higher cost structure and sometimes aren't as able to give as good rates.
Yeah, so that's maybe another sort of trade-off that's worth touching on is that the decentralized and permissionless and trustless participation within the pricing mechanism is possible within AMMs, but it's not really possible in RFQs. You're sort of trusting that centralized pricing if you are providing
Mhm.
liquidity to an RFQ. And so
Makes
that
sense.
probably will affect over the long term the amount of capital locked in each, just because it's a lower barrier to entry to participate in an AMM as far as the trust
Mhm.
considerations.
Do you see any other kind of trade offs in composability with private market makers? Like, is there any other drawback?
Yeah, so the other big one, I guess, is the deadline. So the RFQ trade off is that you are, well, another trade off is that when you're running an RFQ, you're providing a price, but you don't actually know if that price is going to be used or not. You're providing a signature, but it's up to the trader or the aggregator to actually take that signature on chain and execute it. And so RFQs are sort of left in a state of limbo, so to speak, where they don't actually know what state they are in, what assets they hold, because they have outstanding checks that could be cashed, but they don't know when they'll be cashed. And one of the ways that you can sort of deal with this, as you're aware, is to put a deadline on it, right? So that at least limits the time that you can have these outstanding checks. And so when that time expires, you know if that was included on chain, then your the state of your capital reserves will reflect that. And if not, then you can assume that it won't be cashed because now the deadline is passed. From our perspective, deadlines are not great because, and that's part of the reason we generally recommend a slightly higher than market gas is so that you can get the transaction through before the deadline hits in case of any gas spikes or whatnot. So compared to AMMs, where you can of course send a transaction a day later, assuming there's no deadline set there, but generally there's not a required deadline. And if the price hasn't moved, then you're going to get it's still going to go through, right? So generally, you have some minimum amount out you're willing to accept, and that will sort of dictate whether the trade succeeds or not. But there's no like hard deadline in terms of time.
Okay.
And so maybe I guess to go along with that, the trade-off AMMs have with that is slippage, right? Slippage from the price they originally promised. And that's of course something that we have to deal with. I guess as one final note, RFQs in some ways still have to deal with that slippage and changing of price, but they sort of take it on to themselves, if that makes sense. Instead of the trader, they have to deal with the will trades be executed or won't they in front of, and what order will they be executed. I'm not sure if you agree with that. Maybe you can comment on that.
No, I think that makes sense. I mean, you have these shifting of costs and liabilities, right? So in an AMM, the risk of price movement in between the kind of, I don't know, quote and execution, let's say, is borne by the trader and with slippage. And in RFQs, it's a firm quote, and so the risk is borne by the private market maker. And it's, and if anything borne by the provider of liquidity is going to have to, that's going to be a cost. and it's going to have to work its way into the pricing that can be offered, right?
Right.
So
Exactly. Yeah.
if the private market makers are bearing that cost, they're going to have to charge marginally higher prices. And so, and that's going to put them at a slight competitive disadvantage. And so it seems like you have this trade-off between like surety or predictability of a given trade, um, and the time it's outstanding and the price that you'll get on average from these sources. And,
Exactly. Yeah.
and that's just a whole nother set of trade-offs you have to deal with when you're a trader trying to make a trade.
Yep.
It's a complex problem.
Yeah.
Are there any issues with integrating these various sources of liquidity that you feel are too complex or like block you from being able to incorporate certain dexes or certain sources of liquidity because the trade-offs they make just like don't really fit well into your system?
Yeah. So there's definitely some painful ones. I think in general, we can sort of make the integration work. It then becomes a question of will they actually be used and how often. If their pricing model isn't super great, then we're just going to continually pass them up, right? And go where the prices are best. There's also some one thing I will say is that when we're integrating these dexes, we're trying to do so in as low cost as possible. And in many cases, we can essentially execute this large complexity in much less gas than these lower complexity trades cost. And actually, real quick, I want to mention this is especially huge on L2s like Arbitrum and Optimism. So on L2s, what we've done is we've sort of compressed in some manner of the word the call data that describes this path. And so what we see is that like executing a trade on one DEX ends up being like you can add like 10 different swaps to that and you only end up doubling the cost on these L2s because call data ends up being at a huge premium. So if you can manage the amount of call data you're using, your gas costs are way diminished. So in general, we're able to execute multiple swaps in much less gas than it would take to execute each swap independently in a separate transaction.
Can you explain what call data is?
Absolutely, yeah. So that's effectively what if you look at it at a very high abstract level, that's what we're providing. We're like a data provider, just providing call data. And essentially, what that data is it's signed by whoever wants to execute the swap, and that's sent to a node on Ethereum, and the Ethereum client interprets that call data and runs it essentially. So part of that call data is defining what function you want to call, and then that data is passed to the function, and the function can do whatever it wants with it. So that data ends up describing to the function essentially what swaps and what trades you want to make.
And gas costs are much lower on layer twos, and so in some ways that makes the gain from splitting between many different sources and hopping through many different tokens much more relevant because the benefits in slippage and pricing are going to outweigh the marginal gas cost required, whereas on Ethereum that might not be the case, especially for a smaller trade.
Right. Yeah, exactly. And I guess maybe to put it concretely, I'll say that everything is cheaper on an L2 except for data because the data still has to go to L1. And there's some nuances there in how it's written, and maybe you can compress it a little bit. So maybe it is slightly cheaper, but roughly everything is cheaper except for
I
the
see. So
data.
you actually change the way you encode these trades on different chains to accommodate the idiosyncrasies of where transaction costs come from.
It makes a big difference to pay attention to the attributes of a given chain.
Interesting. Okay, got it. Quite a complex problem. Do you feel like it seems like there's this dynamic where there's so many optimizations you could make for every liquidity source, and gas in particular, like you can always get better by optimizing a little bit more. And I would think if you're a DEX aggregator, you're always going to optimize You're going to spend your time optimizing where it's going to make the biggest difference to your users.
Hmm.
But the risk of that is you get this dynamic where, like, all your optimization effort might end up being focused on Uniswap, because today that's 70+% of the market. And then what that does is create a systematic competitive advantage for the incumbent, because other DEXs, which actually may have better pricing, are going to have inferior optimizations for things like gas. And because of that, not get volume, because of that, not be prioritized for optimization. And so I wonder, A, if you think that dynamic exists or not. And maybe let's just start there.
Yeah, absolutely. So I think that is definitely valid in general. I will say that like gas optimization ends up being diminishing returns like a lot of things. And so whenever we integrate a DEX, we make sure we check off the big ticket items, if that makes sense. Like there's some big things we can do to decrease the gas costs of interaction. Beyond that, there is a lot you can of course do, tinkering around, adding more assembly and whatnot, and maybe you can get it down. But I think that that difference is going to be not too significant to make this. Maybe the effect is still there a little bit, but I think it's not going to be massive.
Mhm. Okay, makes sense. And assembly, can you explain assembly?
Right, absolutely, yeah. So generally, you write smart contracts, the code that is actually running all these dexes, and for us interacting with all these dexes, you write them in a somewhat high level language. The most popular one being Solidity, and so Solidity has a compiler that takes this higher level language and turns that into actual bytes that can be deployed and um, basically runs on the network and propagates through the network so that whenever someone wants to transact, they can basically execute using this bytecode. Now, the process going from Solidity to this bytecode, basically, there's a lot going on there, right? And so if the compiler is often not the end bytecode is not often doing what you want in the most efficient way possible in terms of gas that it's using, because you're essentially being charged some amount of gas for every byte there, right? So you can basically get more efficient contracts. So people can basically, the end result is people can execute their trades using less gas if you start to write in lower level. So if you actually start to write in YOL, which is sort of Solidity's built-in way to sort of inline assembly, if you start adding that to contracts and replacing that with the higher level interactions, you're basically closer to the bytecode, right? And so there's less distance to travel until you get to the bytecode, and so there's less room for inefficiencies and bloat during that sort of transition.
Okay, got it. All right, so we have gotten into the weeds here,
Yes.
which I think is really important to understanding actually what's going on. Let's pull out now and consider a question I think this raises for me, which is like, the conclusion I take is it is an impossible task for a trader to go directly in many cases and like try to get the best price for themselves. This sounds like a very complex problem. And yet DEX aggregators only have, 10 to 20% of total volume. Like, why don't they have 80+% of the volume? Why would users not use a DEX aggregator?
Yeah, so I think a large part of that is just they don't know, right? All that. I mean, there's a lot of complexity here, and understanding why a DEX aggregator may provide a better price isn't exactly common knowledge, I think. There is also the fact that this advantage ends up not being massive in some cases. So for like your everyday trader trading on Ethereum mainnet, there's not a whole lot of additional benefit to be provided in some cases. If you're trading a couple $1,000, just going to Uniswap and executing that transaction, there's a good chance we would just route you through Uniswap, right?
I see.
Just because gas cost is so large that you end up having to trade much larger volumes than most people trade for sort of
I
that
see.
that advantage. that
I
to
see. So
utilizing it.
basically, the simpler the trade, the less value a DEX aggregator will add, because it doesn't. There's not that much benefit of splitting it into multiple pools and multiple hops. And then the larger trade you do, I guess, relative to gas expense.
Exactly, that's the key relative to gas.
Yeah.
On something like Polygon, we can almost always do something more complex and provide a better value. So on Polygon, I would say you should be using a DEX aggregator, I guess.
Mm,
And I think
makes
that's
sense.
mainly just a lack of people knowing that
Awareness.
yeah, awareness.
Yeah. Well, I guess there's also a benefit to, like, I mean, you've talked about some of the trade-offs in making a trade, and some traders, and you're optimizing for best price. Some traders might be optimizing for different things. Some people may care more about certainty, uh, and may care less about certainty. And so that may make them want to use an AMM versus a PMM. Some people may want, to pay less gas and take the risk that the transaction fails and be okay with that. Some people may want to, they don't want it, they don't want it to expire, right? They want the quote to be live for longer. I suppose those are all reasons why you might go specifically to a one liquidity source that's built for exactly what you prefer, instead of just optimizing for one thing.
Yeah, so I think perhaps between RFQs and AMMs, there might be room for some wiggle there for sure. Mainly in that sort of guaranteed quote versus all of this composability and everything else we talked about with AMMs. And so I mean maybe that's a feature we should add is to only use RFQs, right? Because you can still aggregate RFQs. And yeah, I guess in general, I think optimizing for output value minus gas value is pretty universal. But you are right. There is some nuance in execution that might cause people to want different things and want to modify that.
Yeah, interesting. I keep drawing in my head this analogy back to airlines. As we're thinking about how the the DEX market will play out, and I keep bringing it back to airlines, where back in the day, I'm sure people, they just always flew Pan Am or something, or Delta, and as that commodified, people use things like kayak more and more and more. And yet there's definitely people who still fly a certain airline whenever they can, right? And maybe that's because they're just used to it. Maybe it's because of loyalty programs, right? But but you see a split between direct access and DEX aggregators, even in the airline space, even in what seems like a very commodified product. And I guess that's probably how the DEX space will play out as well, with DEX aggregators and individual DEXs.
Yeah, I think there is always going to be people who just go to Uniswap, right? I mean, Uniswap has the biggest name recognition by far, I would say. I think over time, the percent of trades going through DEX aggregators will grow. I don't think it will ever hit 100, of course, or get super close to 100, but I think it will grow. Yeah.
Makes sense. I think you're probably right. What One last question, do you think Uniswap is sustainable? Like, do you think those economics even work?
From the liquidity provider's perspective,
Well, really
or
either, because if it doesn't work from liquidity providers' perspective, then it can't sustainably work from the trader's perspective, right? Like, a system can't work unless everyone is better off using it. All the participants are better off, otherwise it collapses. And so I'm
right?
curious what you think the future of Uniswap is.
This is something I would actually like to study a bit more. I don't think there's like, as far as I know, no one's really like tried to study like the returns of different models, including Uniswap, and sort of how these different AMM designs. Everyone there's a lot of reasoning and thought that goes into making these AMM designs. There's less so that goes into sort of comparing them, I guess, and comparing their payoffs and what the actual yield you're getting is. Of course, there's always two components. There's a loss you might actually face as well as the revenue. And so studying how these different mechanisms, like what yield they actually begin to create and are those yields actually even positive, is something that I think needs more studying. And there's a reason why it hasn't been studied too much so far. It's because that number ends up um, sort of relying on future price action, which of course is hard to predict. If you can predict future price action, you can you're there's lots of things you can do with that. That's effectively what concretely evaluating the value of providing liquidity to these pools ends up simplifying down to. So I'm actually not sure how, like, what the yields of these pools are right now, and I'm not sure a lot of people are. Something like stablecoin pools are the only thing I can say are unless one of the stablecoins depegs, of course, those will have positive yield because they're so sort of static around that 1-to-1 exchange rate price. Um, but other things, yeah, it's hard to say, and it's hard to make any sort of predictions of where that'll go without having more concrete numbers on how these pools actually perform as yield bearing assets, essentially these liquidity provider positions.
Makes sense. Well, a conversation for another day and another podcast. So, Matt, how can people learn more about you, follow you, and use Odos?
Absolutely, yeah. So Twitter, Matt Deible, and Odos also has a Twitter, Odos Protocol. So I would encourage everyone to follow both of those, and then check out Odos at odos.xyz.
Awesome. And it's Deible, Deible, correct?
Correct. Yes.
Great. Thank you so much for joining us, for the hard work you are doing at Odos to deliver the best prices for traders, and for sharing your knowledge with us today. Really appreciate it.
Absolutely. Thanks for having me.